Haraden with CDT. Today we're going to actually take a look at a couple things in regards to the new things that we have in regards to Creo. And we've got some things going on relative to some changes that we've actually done here. So if I can pull up my actual screen here and I can kind of show you what that actually conditions are, we can kind of see some of the situations. First of all, number one, we're going to go ahead and I'm going to take just a standard part here, and we're going to kind of take a look at some characteristics of going, first of all, from a standard part into a sheet metal part and see what's actually changed. One of the things that you'll actually do here is you'll actually get into a new part. So typically I will go file new into a part which is actually a solid, and then I'll convert it from there over into sheet metal. There's two different ways to actually do it. You can go into a solid part, but the only thing that you can see is the actual solid condition. So these are some of the things that we actually have in that situation. So these are some of the things that are going on here. So when I actually go ahead and I create something like a solid part here, I'm going to call this, for all practical purposes, sheet 1, and therefore I can put it into millimeters part solid and kind of get into some of the characteristics of that. And as we can see here, we've got a standard part here, and that part that we actually have here is something where we can see kind of some of the directions. So let's get into creating this. In that perspective, we'll hit the sketch, we'll grab a sketch, and I'm just going to make a block for right now just to see what actually goes. So I'm going to convert this whole entire block, which is a solid, into a sheet metal part. And so we'll take a look at something that's actually extruded such that we have taking something. And I'm doing this in basically simple form so we can understand some of the things that have changed within the Creo 2 application of sheet metal. Now, for us guys that have used to and are used to using the flat state, you cannot by the standard default. You have to change some of your configurations within the Creo 2 characteristics. And some of these Creo 2 characteristics aren't merely the same as, but we've changed some of the configurations around, and we'll kind of talk about some of those things. So if I get into this, as you can see here, there's some things that we want to take a look at. One, we've got an extrude here, and we've got some conditions. So as you can see, there's nothing here in regards to sheet metal. I can always use the search tool here to type in sheet metal to find out if I can't find anything. And this is something wonderful for Creo 2 is that this becomes a function. As soon as I select and hover over this blue area, notice it does a pull down over here on the left-hand side where you can actually see convert to sheet metal, and that's what we're going to actually do. So go over here under operations and convert to sheet metal. Okay? And these are some of the things that we'll actually see relative to that. And so what we'll do here is in the conversion of this, I'll go ahead and close this out, and we can put any we want in here in regards to Creo 2. But because we've got a volume here, we have something like a shell. Okay, and in that shell, we have a situation where we can actually define the thickness of that material. So we can actually hit 5, and now we can actually select that feature that we actually want to take away. So if we take this away, you can kind of see that we have a model that's actually going through. And it's not, when we check OK, it's going to give us our thickness, and we're going to see the shell. Now, people think that, oh, we've got some nice things going on here relative to it. But one of the things that we have is the conditions of the actual flat state. And one of the things that we have to do within the flat state is do some configurations. We look like we're actually in sheet metal. We are not. We have to actually use a conversion. And this particular shell will never go flat unless you actually put rips alongside of it or some kind of relief where you can actually get it to go flat. So that being said, I'll use the conversion tool, and I'll use some edge rips. And as you can see, we've got 4 new icons, no longer the pull-down menu that used to be over here on the right-hand side. So we've got an edge rip that actually is there and designated by that icon. We can select this icon here, And this is something new for Creo 2. As you can see, as I'm pushing the features through, it will actually take and show what it's going to actually do. So it's like a pre-selection, and you can see what's actually going on as you select your geometry, which is kind of cool for Creo 2. And if you zoom in here, it actually shows it as a pre-loaded form where you can see the relief of what it's actually going to rip. And then once we actually go ahead and say OK to it, we can do a preview to it, or we can do an OK to it, and we can actually kind of see that characteristics of what's going on. So in this, we can actually say OK, and we've actually got it now fully conversion. So when I see it in a shell, now it went from a solid to a shell, and from a shell to a conversion, and actually get this to actually happen. So these are some of the things that we can look at and get into. Now, based upon this, then we can actually go into some of the characteristics. And as we've got some options here, and we've got some characteristics. So if we go under options here, we've got a configuration editor. We've got to find, and what we can say here is flat. And so if we go ahead and designate and find flat, notice it's got to be, there's an enable underscore flat underscore state. So unless we have this changed, which is a standard default in Creo 2, and this is where I've always wanted to actually get into a flat state. And unless we change this from no to yes, you will never be able to create this flat state in a family table type scenario. So once we get into that, then you can actually change this over to yes, and now add change to it and close. So we can see that I've actually got this in my configuration. So enable flat state set to yes. So you look at it and you say, okay, so now we've got our flat state actually enabled, and some of the things that we can actually do, and some of the things that we can actually get into is, let's try to create this flat state. So you look at it and you go, well, there's nothing that seems to be up here at the top under flat state or fill or anything here. How about analysis? Is it there? Well, there's really nothing there. Annotate? Not really. Render? Not really. Tools? Not really. There is a family table here, though, but there is no real flat state to actually do that. And so once you go and you get into the condition, you can see that there's nothing here that shows flat state. And so what I usually typically do is I go back to the model, and you can kind of see some things here. If I go under File, then I go under Manage Session, I can kind of see something there. So if I go under Prepare, and this is where it's actually hidden, is under the Prepare tab. So I'm going to actually prepare this model for the model properties. Now look at this. There's a flat state instance that this whole thing gets changed around to. So I can see the bend allowances, I can see the bends, the release, everything else. And yes, last but not least, unless we have that configuration, we don't see this flat state. Now, in this flat state, this is where we can actually create this. Now it's like what we used to see in the old pre-Creo 2 situation where we can actually create the flat state. And so I can hit the create. Notice the fact that the flat path that's actually getting done is the file name underscore flat 1. Now, if for some reason you want to change that relative to your family table so that you can put it onto the drawing so that you can actually use those as the primary and secondary views and get into that as well as the isometric view, you have options for two models. And that's what I want to actually show here in perspective of it. So if we look at this, and there's some things along the way here that I want to talk about. One of them happens to be with the Sheetmetal phases of the family table. And if you look at the family table itself, once we say OK to it, it's going to ask us some real interesting questions here. And the questions are, what do we have here in relative to the part? Do you see any kind of indications down here of what kind of state? Yes, there's a current part state. Select the current. Is it fully flat or is it fully formed? In this case here, it's fully formed. So once we select that, this is something new for Creo 2. So it's going to give you kind of more or less, as long as you've got this set up, kind of a preview of what you're going to create in your family, in your flat state. So it's kind of something that's kind of interesting in that perspective. So you can see how these things actually go through. And so when you've got this, what we used to get in the old software like pre-Creo 2 is we'd actually get a flash, and then you'd have to go in and open up that particular flat state. Where here it's kind of nice because you can see, yes, I've got this. Will this actually work? You can kind of look at the characteristics of what's going to happen in the flat state. So the flat state equals this. And when we check done, notice the fact it goes back to like what we actually had. So if I want to show the flat state, I can actually get into the flat state, and it's just like it was where we actually have the characteristics of some of the situations. And when you go into some of these characteristics, you have some of the flat states and some of the reliefs that you can actually do. And you can get into, you know, like a corner relief or whatever, and so you can actually change some of the corner reliefs and get into that. And once you've selected that, you can go to a V-notch. Oh, let's see what we've got here. We've got a circular relief. Or maybe we've got something that is rectangular. Ah, this is something brand new for Creo 2. And I like this because it gives you, you don't have to sit there and fight with that particular relief. And it's just real simple by actually pulling this pull-down menu here. So I can do an oblong or an oblong. I can get into a no relief, a V-notch. I can get into a circular relief, a rectangular. So you can see kind of what I'm talking about by a circular relief. So we can actually get into some of those characteristics. Or maybe you're like, we want to go to a rectangular relief, and you can kind of see how that actually looks. So you can change those based upon that actual flat state. And as you can see here, if we go back in, we can see some of the characteristics of what's going on, and you can see that flat state change. And that's something that I really like about the Creo 2 sides of things relative to those types of conditions. So that being said, we can say done, and what I'm going to do here is I'm going to close this particular part down, and then what I'm going to do here is I'm going to act on the family table. And notice for the first time since we've been in the Creo 2 side, we can actually get the automatic fill out of the family table. Now, unless you have that configuration set, there are some other things that actually happens, and you will not get this. You have to take the family table and manually load it. So this goes into something like this. From here, you can take things and put it out into Excel, as you can see, in relative to the family table, and change whatever you actually physically want. So you can see the differentials, and so you can import and export that. Now, one of the things that I want to talk about here is relative to family tables. And so many times, the reason that there are issues with family tables is there are a lot of things within the family table. So every time I hit save, I like to actually set one of my configurations to help my PDM system and help everything kind of talk to each other relative to that assembly. So if I go under File, I go back under Options, and I go under Configurations, I have a condition where I can see some of the characteristics of, well, if I look at Verify, so if I type in Verify, and I see where Verify actually is here, I can see that I can verify on save by default. And notice that when I do that and I select this, the default is always no, and I want to actually go back to yes. So when I put that in the configuration, it's actually there and in place. So once you've got that in place, then you can actually do a verify when you hit save. Or you can manually do it, which actually is showing here as an unverified family table. And this is what it defaults to. And some of the people in the family table industries of checking these into a PDM system have problems. And you can see that this is actually unverified, and now you've got full success with it as being verified. And then once you say okay to it, now you can actually save it and get into some of those characteristics. So these are some of the things that we can actually get into. We have a totally different format, like we have flats and edges and rips and planars and things like this. Now, one of the big things that we have changed here is where we get our rips from. Now we've gone all to like a surface rip, an edge rip, a sketched, a rip connect. So these are things that we used to have in a pull-down menu, but now we have actually icons. Same thing for the form. So we've got a punch form, we've got a sketched, we've got a die form, we've got a flattened form. And so these are some of the things that you actually have here. I've got corner releases, which I've shown here, and I've also got things like unbends. So I can go back into unbend and transition. So these are some of the features that I physically have. I can get up into an edge bend or a planar bend, so I can kind of see what those actually are and what they actually do. I can also have these pull downs, and as you can see, I can do a split area, I can do an offset for a surface, I can do a family just table directly from here. If I do a family table directly from here, you can see that that actually happens. In my model intent, so I've got things like relations, parameters, that are all sitting underneath the model intent over here, the published geometry, switch, the pro program, and so on and so forth. I also have things such as the freestyle surfacing and everything else. Also, I can merge. So if I want to take a sheet metal merge and kind of join these kind of sections together, I can do that. So these gets into some of the conditions. So every one of these in sheet metals has a bend order, so I can change the bend order of how I want to actually get into. I can look at the notch, the punch. If I look at a punch, you can see that it's going to actually ask for a punch. So I've got to have that particular punch preset up for that particular tool. So you can see some of those characteristics. I can get into some of the cosmetic things like holes, rounds, chamfers, grooves, and designated areas for maybe for like, well, what we call like darts and so on and so forth. So we can designate some of those areas. We can get into revolve and twist. So these are two common things that we used to see in sheet metal all the time. So revolve and twist used to be in an icon flying out over here on the right-hand side. We can also get into data, where we've got some things that we bring in here. We might want to bring in a graph. We might want to bring in a default coordinate system. And last but not least is importing, the merge inheritance and importance. So those are pretty standard. Those are some of those items are actually outside of the sheet metal, but this kind of looks like something that's kind of different here. So we can get into that. And then, of course, our normal resume all, and scale, and switch back and forth. So these are some of the things that we actually have. Now, one of the things that I like to do here, and I've kind of something that I've found relative to a flat state. So one of the things that I like to actually look at is how to start a part, let's say from a sheet metal part, and now convert it. So this one was a solid. Maybe I'm starting out with a flat, and I'm going to be like forming it so that I can actually put it into a break and then just allow those to actually formulate and then create my flat states from there. So let's try one of those and see if it looks a little bit different. And it does, because we're going to have a totally different set of commands to actually pull through on. So we can do that. So with that being said, we can go under File, New. And then in this particular case here, I'm going to go to a Sheet 2, which is a new part. And I'm going to go into Millimeter Part Solid. And I'm going to go ahead and start this off with a different type of condition. So I can see the top set, and I can actually get into. So I'm going to sketch actually a rectangle that represents my flat state of my piece of sheet metal that I may have picked up as a piece of scrap, or maybe I have it coming off a sheet metal roll and stamping it out thereof. And that's fine with me. And then you can actually go ahead. I'm just going to take some dimensions, and you can see when you're in sheet, the actual true part, your actual dimensions actually show up. It fills the actual section up. And this is something that I like with Creo 2. Doesn't matter whether we're in Sheetmetal or Part, you actually get the same under the sketch command. It's something that we used to do in the old series where we go under File and then we can go under Edit and then fill that particular sketch as long as we have it highlighted. Now it does it automatically for us, and we can tell, yeah, hey, we've got a good section there and there's no extraneous lines that are outside, and it makes a true fill blocking. So we can say okay to that and get into some of that characteristics. And then what I'm going to do is I'm going to actually extrude it. And this time here, I'm going to use a 5mm thickness to represent my sheet. So this is some of the things that we actually have here. And relative to that, we have some conditions. So we can see, number one, that we've got a 5mm solid part as we've got here. And we can actually go ahead and start to convert this now into sheet metal. So I'm going to go under Operations and then Convert to Sheet Metal. And this is where it's actually buried again. Now notice the fact that I've got surface, driving surface, and shell. The driving surface means, okay, I'm going to start with a flat sheet of sheet metal and then start building it up from there. And so one of the things that I actually like to do is to actually do some conversions, okay? One of the big things that we actually have here is the flat state. And one of the things that when I was over in Thomas Buses is we actually work with these flat states. So in a pattern shop, what you do is you'd start off with a flat. They might take and either laser etch this and cut it out, or they may take an awl and actually just trim it out with a nibbler. And then you put it into break and formulate and bend it all the way up. So these are some of the things that we actually have and in place. So we can actually get into that. So if I say this as a driving surface, now I can actually put that actually in, and notice the fact that we'll put this in as a 5mm thickness. And then once you've got that actually in there, we can actually see some of those things. So these are some of the things that we've actually got relative to that. And so one of the things that we can actually do is get this converted into it. So we're going to hit the driving surface, and then I'm going to actually grab the back side of this, which will now automatically change that. Notice the first time I did that, I wanted to physically change that. And that's what a lot of people do, is they go in and change that number, and now you just have another solid part again. But if you actually select that surface to be released, now you can see that something's being changed. And one of the things about Creo 2, it changes it to this orange color. And you can change this coloring based upon some of your coloring schemes that you have within that. As you can see, we've got a reference. We've got that surface. We've got some options here. We can set the driving surface opposite the selected surface, and you can check that. We can also name this of whatever we want. And then once you get into that, you can check that. Now, with that driving surface, we are actually physically into sheet metal. And these are some of the things that we can actually get into. Now, before we actually go, and I like to actually set this before we get into sheet metal, one of the configurations that I like to set up for sheet metal is this, so that when I create the flat state and start bending it up, I can average some of my rounds that are actually going through and kind of go through. So if I go in here and I set up initiation for the actual bend radius, I can type in initial, and you can see that the initial that I actually have, I typically like to use 0.7071 or the square root of 2, so that when I lay that flat and that averages through based upon my selection. And the important thing is the way that I select it in the geometry itself. Typically we have a value set here as 0.5, but if you do this in this fashion, I've tested out the value of 0.5, and I've also tested out the 0.7071, and what I found is that when you do this and you use like 2.5 times the material thickness for the radius, you usually come up with a pretty good value in regards to that average as it goes through that curve. So I'm going to go ahead and change that, and you can see that that actually is in there, and now we can say okay to it. Now ask me whether I want to save it or not. I can say yes or whatever and say okay. So those are some of the things that we can actually get into. Then, now I can start my actual bend. And so it gives me some characteristics of what I want to see here. Notice there's a placement. So it says sketch on a surface of a detail. So I can actually select that surface and get into that. So these are some of the things that we have. Notice the fact that we have some characteristics of some new icons. Notice we have an icon here called bend material up. We've got a bend material other side of the bend, and then we've got both sides. So these are going to be some new icons we have. We no longer have these little pull-down menus that are actually in place there, so you can kind of see what's going on there. And so we can get into such things as that. Maybe we want to get over into the bend line, so I want to sketch that. So these are some of the things that we can actually do and get into. So I can actually get into some of the actual. If I hit the sketch, notice the fact I can hit sketch directly, and then I can actually go into the line. So if I go into here, and I can actually get into a line itself. So I've got a line chain and a line tangent. I can go in the line, and I can go ahead and sketch this a lot. And this is where I'm saying it's a lot different in Creo 2 than what we've seen in any other release. So these are some of the things that you can get into in some of the characteristics. Once I have that, I can let dimension, and I'm just going to let us actually dimension that, and then I'm going to do a Control-D, and you can kind of see a preview of what's going to actually happen. So this thing is going to actually bend down here. And one of the big things that I've noticed in regards to this, a lot more configurations that we can do. We can do a bend line, we can do a transition, so we can add some of the transition. We can add a relief if we want to. Maybe we want to add a rip relief, or maybe we want to get into a sketch, rectangular, oblong. So these are some of the things that we can add. Before all we had was just pull-down menus. And this is some nice things in regards to Creo 2. I think this is much more forgiving and easier to actually do. If I wanted to define each side separately, I could actually do that if I wanted to. So if I check this, notice I can go side 1, side 2, or whatever I want to actually do there. I can actually allow a bend allowance. So I can actually, by the K factor, by Y factor. That what initial Y factor is what I'm actually setting. So I can actually get that through my configuration. I can get into properties and call this a specific bend. So these are some of the things that we can actually see here. And notice the fact it shows what it's actually sitting at, so we're going to take this and bend this downwards. If I check this and say OK to it, let's see what happens. Aha! Look at that. It actually took and bent that part up. So we can actually do this. Now, there's something called the flat pattern here. And I am not a real big fan of flat patterns, both in any software that I know to the engineering world. And particularly the reason why is if I put a flat pattern here, it's going to actually stay here. And it's never going to be the very last feature of the model tree, where if I go to a flat state, I get this model tree to actually look like that. And it always, no matter what I put in there for inserted features, it keeps that flat state at the very end. Plus, on top of it all, I get a little bit of better inclination of what my flat state's going to look like before I finally say OK to it. And so I'm really not a big fan of flat patterns. I know there's other competitor software out there that they actually say, we like flat patterns, and all that, but it's just one of those things where you could go ahead and do it. But wherever you put that in your model tree, that's where it's going to stay. And that's what I don't like about a flat pattern. Where a flat state, it's always going to go to the very bottom of the model tree. And so this is the last thing that I usually like to do, because it's something that we can actually get into. So I'm not a real big fan of the flat pattern. And you can kind of see, if I take a flat pattern here, you can kind of see what actually happens. And it'll actually drop that flat pattern right there. And so you can kind of see what's actually going on here. Now, if I go back in here and I right-click and I delete that, thank you, I can actually see some of the characteristics of what's going on relative to that. So I'm going to go ahead and do that, and I'm going to edit definition, and get back into my flat pattern here. And now if I go ahead and I hit both states, now I'm kind of like more or less averaging where this actually is going to be coming across. And then if I say OK to it, now the center line is going to actually go across to the center. And when I get into that situation, these are some of the things that I can go back in and always redefine. I can actually go in, add a definition on it, and I can see whatever I want. If I go through there, I can change the location of the fixed side. I can flip that. Let's say if I flip that, I can see that those are going to flip relative to those directions. I can also go in and define the bend angle. So I can say, okay, I only want it so many degrees. I can also go ahead and bend the end surface, almost formulate like a hem. These are some of the things that we can actually do. And these are kind of neat in Creo 2 because you have that characteristics. We have a thickness here. We also have 2.5 times. This is where I was actually, maybe I want to enter my thickness. So here again, I can put in a value where I can say, okay, let's enter the thickness. And I'm going to put in here 2.5. And then I'm going to hit the asterisk, and then I'm going to put in 5 millimeters, which is my thickness. And then when I actually enter, notice it changes it directly to my material where I can actually bend that round actually up and in place. And then you can actually see some of the pull downs. So you can say, okay, here's a resulting internal bend, and there's measuring the angle deflection from the straight. So there's some new things that we've actually got put in here. We also have some characteristics of, we can see the dimension on the outer surface. We can see it on the inner surface. And then we can see a conversion from the inside of that radius. So this is something new for Creo 2 as well. So there's a lot of things that they have done in regards to the sheet metal. And it's great. It's wonderful. And once you say OK to it, then we can say OK, and now we've got the actual bend. And as you can see, this is a relatively easy bend relative to it, and you won't get any fracturing across here. So these are some of the things that you can actually get into. When we get into things bend order, we can change some of the bend orders. We can get into some things where you get into the merge, and so you can merge kind of some of those walls together if you want to. So those get into the more advanced side of the sheet metal. Then once you get into that, then you can go in here, and then you can go under File, then Prepare, and now you can go under Model Properties, and now you can say, there's my flat state. I can say Change, Create. Yeah, there's my Sheet 2, Flat 1. I can say, yes, that's what I want. And now ask us, do we want it fully formed or fully flat? Is this fully, what area are we in? Is this a fully formed part, or is this a fully flat? This is a fully formed part. And as you can see here, now it actually takes and highlights those references. And then once you get into that, then we can say done, okay. And then you can go back in here and now show it. Now, this is one of the things you can do is you can show the flat. You kind of see by actually hovering over that, and this is one of the things that I found within sheet metal that was always an error. If you didn't select that both sides, what would happen is that center line. So let's say I wanted to do something that was basically cheap and dirty, and that is that I wanted to actually take a bluing like we used to do in the old sheet metal shops. We'd take that flat sheet and actually use a bluing on it. Then we'd take a 1-to-1 scale of that actual drawing, cut it out, and lay it on top of that sheet. And then we'd actually take an awl and etch where we're going to actually put that actual line in. So when we put it into the break, we could line it up, and therefore when we bent the radius, that flat pattern would actually make the right part for what we actually are seeing. So therefore we didn't formulate the round too quick or too far behind and get the correct part. And so this is something that we experimented with quite a bit when I was at Thomasville Buses, and we found that when it was there and in place, we could do our flat states all the time, 100%. And when you actually created the flat state on a 1-to-1 scale with a drawing, you could create basically cheap and simple. And you didn't have to go out to a special shop to have it laser cut and bent, and you're sitting there playing with all this kinds of material. So it's something that I have really found between that and the initial Y factor set to 0.7071, between those two things, that gives us an exact flat. Now, and the axis for which we actually have here on one side or the other, if we don't have the initial Y factor set, it'll default to 0.5, and it'll always give us about 2 or 3 units of a deviation, whether you're in inches or whether you're actually in metric, off. And we could never get that flat pattern exactly straight on. Plus, on top of it all, the way that you actually select the part in the driving surface. So I usually like to use the driving surface of the green side always to the datum plane, and it seems to work relatively decent. Sometimes you can flip that around too as well and get into those types of situations. So those are some of the things that we actually see. And then when you get into that type of condition, then when you put it into a drawing, you can actually use that. So one of the big things that you do is that when you see a drawing in that perspective, you can see that flat. So if we go under File, New, and then drop in a drawing here, we can actually do, I'm just going to take a template for which I have. I think lost some phone here, but anyways, we can grab something that I have here. Let's see if I've got something here. Let's see if I can grab one of these and to kind of take a look at that. So I can grab, maybe let's go into one of these here. I can just take in, yeah, let's just take and cancel this. Let's just go and grab one of these. Let's just do, let's see what we got here, see what actually happens. So you can see that we've got the actual flat state. And we've got that actually in session, and you can see that those actually are. And if you kind of zoom up on these things, you can kind of see where a lot of these axes are and everything else relative to it. You have things where you can get into annotate, and then you can get into some of the types of things where you can get into the symbols, the dimensions, and some of the things. So you can see by what's going on here relative to that type of condition. If I want to, I can always add another model to that. So if I go into the model, I can actually go into add drawing models, and now I can add my drawing model, which I have in session, which is basically my sheet 2 part. And now I can say, yes, do I want the generic or the flat? I can see the generic. And now what I can do is put the general view in here and say, okay, and now I can actually place that. I can put that in as the isometric. And then I can go into the flat states. I can shade this up with edges, and I can say apply and close, and there's my actual part. You can see the actual edges on it. Or if I want to, I can go in here and change my characteristics. So the right click and hold will actually change some of the characteristics for that particular view, and you can actually see what's going on there. So those are some of the things that I actually see in regards to sheet metal, and you can kind of see some of the characteristics of what's going on there. Now, if I go back and I close this back out, and I go back to my model, and I close this back out, now I'm in my flat form. If I go into my flat state, I can actually see that this. And unless I hit save with that configuration, and I'm going to go ahead and hit the verify of the family table, notice that it's already done when I actually have that in configuration. So it automatically verifies that particular part and gets off into that particular area. I can also get into changing things. So if I want to, I can create other flats and other bends and add those in and go back and forth. I can export this back out if I've got Excel actually loaded, or the actual Microsoft Office. If I don't have it loaded, of course, I can't do this. So these are some of the things that we can actually do and get into. So we say OK to that and get into that. In perspective of this, we also have things where we can actually take an offset. So we can create an offset. And as you can see, is we can actually grab some of these characteristics of the references. So we can grab something like this, and now we can create an offset from that. And you can see that there is another full part relative to that offset. It's kind of neat, kind of different. We get into such things as the conditions where we can go in and we can actually go in and edit some of the edges and rounds or whatever we want to actually do there. We can go in and get, so if I want to actually go in here, I can get a stretch form, I can get a punch form, I can go in here and I can rip whatever I want in that perspective. I can get into some of the characteristics. Notice I've got an unbend that's actually there, so I can unbend some of those characteristics. If I want to, I can actually take and extend this. So if I want to take, I can actually take and extend that piece of sheet metal as it goes through. Notice the fact that I've got different icons. It says here, extend the wall in the up reference of the plane, extend the wall in the intersection of the plane, and then extend the wall by value. So I can actually do that. So I've got some options here relative to that extend wall. Plus, on top of it all, I can right-click on here, and we've got some new conditions. We can say normal to extended edge or along a boundary edge. So these are some of the things that we actually look at in regards to some of the surfacing. We've got references, a course tab, and that's picking up that edge. And then you've got an extension. So you've got the extension of the first side and the second side. So you can take a look at those types of conditions. We've also got an attached. We can actually use it as an unattached wall. So we have an options of either and getting into that. So these are some of the things that we have. Once we say OK to it, now we've actually got an extended wall. And you can see where we've actually extended the wall. Now, in our old icons that we used to have, it used to be on the right-hand side over here and get into some of those characteristics. Notice the fact that we've got a flat pattern preview. I actually like the flat state, but you can actually do a preview of it if you wanted to. You know, it's totally your objective. If I want to take a flat surface and fill that, I can actually fill that and get into some of those characteristics. Also, what I have is I can join and I can pattern some of these characteristics. So I can use a pattern table, I can use a merge, and I can use some split surfaces and projections. I can also get into the styles, so I can actually do some of those characteristics. So these are some of the things that we have. I can do a bend edge. Let's say if I want to, and I want to take something like a hem. Can I actually do that? And sometimes they actually do some of those characteristics where we actually have this. Now, some of the things that we can do is we can create a flange. So we can actually create a flange and select an edge. So you can see how that actually works. And as it goes through, we can extend whatever we want. Maybe we want something that looks like this based upon that and get that to actually happen that way. So you can see how easy. Maybe we want to create a flat. So we can actually see on this flat here what's actually going on here. So I can actually add this flat and put that actually into some of the characteristics. So that gives you kind of an overview of what we actually have. And there's a lot of nice things that have been actually idealized in this little icon tree and in the icon list. And these are some of the things that we can get into. You can actually get into the planers. So I can create a wall, or I can create anything. Or I can put a solid feature into this as well. So these are some of the things that we can get into. So that being said, if there are no other questions, I pretty much have gone through a lot of these characteristics. I love this search bar because, like I say, if there's something there that you can actually see, You can kind of highlight it, and it'll actually show where those things are actually at. So you can get into some of the conversions. So it's going to say, I got to be over here in model, and then I can actually hit this, and now I can see where that actually is. So these are some of the things that we can get, and we can also, this is one of the other things that's kind of neat within Creo too, we can switch back to a part too as well. And it'll say, well, do you want to collapse this? Do you want to delete this? What do you want to do with these? So you can see some of the characteristics. So I can go back and forth between these. So I can delete this flat, or I can delete whatever, or I can collapse this and confirm. And what do I actually have? So I got some independent geometry that actually is developed. So kind of neat. And it goes back and forth in between that. And I can go back and forth in the sheet metal, and now I can drive those two characteristics. Now, I primarily would not have two of these sheets on here. I would have something else. But for all practical purposes, I can look at the solid surfaces of it, and you can actually see by right-clicking on it. So those are some areas that we have.
We do have a question, Bill.
Yes.
And it's, what's the difference between flange and flat commands?
The flange is allowed, kind of as you can see here in the six. You can see that it's a lot tighter, and it allows this radius to change. So it's a little bit more curved. This one here is more or less a straight curve across that, and that's the difference between the two. So when you actually look at those particular parts in regards to the sheet metal and the driving surface, if I want to pick a driving surface here, and then I can say OK to it. Now this particular one here, because I got this other piece up here, is something that we'd have to eliminate and get into. But that's the difference between a flat and a curved. Any other questions?
I don't see any at this time. Oh, I just saw one pop up. Let's see here. When doing a punch part, I used to be able to add a radius to the part, and it would show up. Sorry, it's kind of small print. It would show up in the sheet metal part. Now it seems to fail. Has that changed?
Run that by me one more time, Rosa.
Okay. Tony says, when doing a punch part, I used to be able to add a radius to the part, and it would show up in the sheet metal part. Now it seems to fail. Has that changed?
Yes, you have to create the tool first with the round, and you have to make sure that when you create that tool, that the datum plane is relative to the bottom surface of controlling the punch. If you don't select that plane to that surface, it will fail every time. So let's say I have something that looks like this, where let me create something that will actually go through that. Let me kind of look at something where, let's do a new model here, and I'm going to call this one punch, just so we can actually take a look at a punch itself. So when I create a punch, what I'm going to do here is I'm going to create that punch so it's on this flat, so I'm going to sketch on this top plane, okay? And so when I do that, I get into the situation where we can actually create this flat, create the solid to that. Let me just kind of get in position here. And notice the fact that I've created this top plane here. And then once I've got that in there, then to create that punch, I usually go to the back side of this. I sketch on the back side of this. And now when I do this, I can do a circle like this. And then I can create that where I can formulate a punch. And then I can extrude it back down out of here. And now you can kind of see that I've got a punch formulating here. And the key is this datum plane has to be relative to that surface. Otherwise, I have seen issues where it fails regeneration based upon that. And when you pound the round actually into that, and you get the round here, and you get the round over here, you can see that these rounds, which would be a typical form of a punch. And what happens is that based upon these rounds right here, if you don't have this datum plane setting here with this extrusion up here, it'll fail it every time. So good question. Any other questions?
I don't see any at this time. If you, I think one, someone just said thanks. We can go ahead and wrap up if you'd like, and I can make sure that the video is available on our YouTube page after the webinar.
Wonderful, wonderful.
And if
no other questions.
If there are any additional questions, feel free to email me, rosalinda.eanes@cdt-bw.com, and you should have my email address if you registered for the webinar. So thanks for attending, and we hope to see you next week. Thanks so much.
Appreciate it. Thank you. Thank you, everyone. Bye now.